I am going to solve a projectile motion practice problem for an object that is launched at an angle on flat ground. It says fired at an angle, but really launched. So here it is. A soccer ball is kicked at 12.0 meters per second at an angle of 43 degrees. We need to find the horizontal range of the projectile. And then we are given that the soccer goal is 2.44 meters high and 10.9 meters away from where the ball is kicked. If no one blocks the ball, will it go into the goal? So I'm going to zoom in and let's get started. So first of all, since our ball is kicked at an angle, we're going to need to find the components of the initial velocity. So since our initial velocity is u equals 12.0 meters per second, we need to find the x and y components. Let's draw our vector triangle. That's ux. This is uy. And the angle is 43 degrees. So to solve for ux, I'm going to use cosine. Cos of 43 degrees equals ux, adjacent, over hypotenuse, 12.0 meters per second. So then that gives me ux equals 12 meters per second cos of 43 degrees. And calculator says that that answer is 12 cos 43, 8.78 meters per second. Meters per second. Same thing to get uy, I'm going to use sine, opposite and hypotenuse. Sine of 43 degrees equals uy over 12 meters per second. And we solve it, we get uy equals 12 sine of 43 degrees equals 12 sine of 43, 8.18 meters per second. 8.18 meters per second. That's ux and uy. Okay, so now we can start solving. If we want to find the horizontal range, then, well, let's just do A over here. I'm going to set up my t-chart for x and y. X, we have S, V, and T. Y, we have S, U, V, A, and T. We know our initial x and y velocities. In the y direction, our initial velocity is 8.18 meters per second. Our acceleration is negative 9.81 meters per second squared. And, well, if we're looking for the horizontal range, that horizontal range is the horizontal distance it travels when it reaches the same height. So the vertical displacement, Sy, is going to be equal to 0 because it lands at the same height that it's launched from. So there's another given. And in the x direction, we know our initial velocity is 8.78 meters per second. That's also our final velocity. That's our velocity at all times, 8.78 meters per second. And, okay, so we can get solving. If we want to find the horizontal range, we're really looking for Sx. So we're going to need the time first, and we can use the y component to find the time. So we need to pick a Suvat equation that lets us solve for time. I'm going to do S equals ut plus 1/2 at squared. S is equal to 0. U is equal to 8.18 meters per second times t. 1/2 a is minus 4.905 t squared. Well, this is a quadratic. It's hard to solve. We could solve it graphically. I'm going to factor out a t. 0 equals t times 8.18 minus 4.905 t. So this is a little bit easier since the left side is 0 and it's 0 equals a product of two things. Either t could be 0 or 8.18 minus 4.905 t could be equal to 0 and that still be true. But we know t equals 0 isn't the right solution because that's just right when you kick the ball. So let's solve for the other solution. 0 equals 8.18 minus 4.905 t. We rearrange it a little, we get 4.905 t equals 8.18. Remember that 8.18 is meters per second. 4.905 is meters per second squared. T is then going to be equal to 8.18 over 4.905, which is equal to 1.67 seconds. So I'm going to fill that in my table. 1.67 seconds. That's also the time it takes in the x direction, 1.67 seconds. And so I can now solve for my horizontal displacement. Just cordon off that one. So in the x direction, displacement is just equal to x velocity times time. There's no acceleration, so there's no a, or a is equal to 0 in the Suvet equation. So it's just equal to 8.78 times 1.67. S equals 14.6 meters. Here's our answer for part A. 14.6 meters. Okay, well, part B is a little different. Part B says the soccer goal is 2.44 meters high and 10.9 meters away from where the ball is kicked. If no one blocks the ball, will it go into the goal? So this is a yes or no question, but we're going to have to back it up with some math. So I'm actually going to slide over to the right, so I have a little bit more room. Well, that didn't work. Okay, let's slide over to the right for part B. Now, if you think about what's happening here, we have a goal. It's a certain height, 2.44 meters, and it's some distance away, 10.9 meters away from where the ball is kicked. So there are three possible outcomes. One, could kick the ball and it goes over the goal. That's a miss. Two, could kick the ball and it goes in the goal. Or three, could kick the ball and it doesn't reach the goal. So we need to determine whether or not it is basically in the goal when it gets to this distance away. So we can start setting up our t-chart. Again, it's going to be slightly different values because we're not looking for the horizontal displacement when the height is 0 anymore. What we're really looking for is the height of the ball when it reaches that goal. So we actually know our x displacement is going to be just the distance to the goal, 10.9 meters. And we already found the initial velocity in the x direction. That's 8.78 meters per second still. We don't know the time it takes to get to the goal. In the y direction, we're trying to find the height. This is our unknown that we're looking for. We know the initial velocity is 8.18 meters per second. We know the acceleration is negative 9.81 meters per second squared. We don't know the time, and we don't know the final velocity in the y. So if we want to find the y displacement, we're going to need the time it takes to get to the goal. And we can use the x component of motion to figure that out. So let's do that. In the x direction, speed is displacement over time. Because there's no acceleration, velocity is displacement over time. We solve that. We get time is displacement over velocity. So that's going to be 10.9 meters over 8.78 meters per second. We get our time to the goal. Time to horizontally reach the goal, at least, is, in my calculator, 1.244 seconds. I'm going to fill that into my table. 1.24 seconds, 1.24 seconds. Now I can use the y component to find the height of the projectile at that distance away. Now, the math doesn't take into account the ground. All it takes into account is the givens that we shove in. So the math assumes that there is no ground. So there are three possible options we could get for our displacement. It could be negative, which means that our projectile ends up below the ground at this point, but that really just means it hit the ground somewhere before the goal. It could be between 0 and 2.44, which means it goes in the goal, or it could be over 2.44, which means it misses the goal. So let's solve for that displacement in the y direction. Since I know SU, or since I want to find S, I know U, A, and T. I'm going to use this equation, S equals UT plus 1/2 AT squared. It's already solved. S is equal to 8.18 times 1.24 plus 1/2 times negative 9.81 times 1.24 squared. And I plug that into a calculator to get my vertical displacement. (8.18) times 1.24 plus 0.5 times negative 9.81 times 1.24 squared gives me 2.60 meters. And that's really what I need to answer the question. So for part B, my answer is going to be no. The ball goes over the goal, because 2.60 meters is greater than 2.44 meters. So that's that. There's our practice problem for projectiles fired at an angle. In summary, solve them the same way we do every projectiles problem. Initially, we need to take the x and y components of the velocity, and then we just plug in our values to the t-chart, solve for our unknowns using the Suvat equations. Hope that was helpful. Bye.